Hi, these are our cats. So I just figured I'd start with that and then move on to the actual topic, which has nothing to do with cats. So yeah, this is talking about using TypeScripts to get fewer bugs, or at least discover the bugs a little quicker. If anyone's seen this version of the talk at Camp.js, the actual title of this talk is Getting TypeScript to Help Me More because I make a lot of mistakes. And it is at least the theme of this talk, if not the actual title. So mundane things first. Yep, my name is Rob Howard. I am around on Twitter as Dan Cabbage. This is a more accurate photo of me when I'm working from home, which I do a lot because I work remotely. And I want to kick this off with a little bit of audience interaction. So first, chuck up your hand if you've never used TypeScript at all before. Cool. All right. Who's mucked around with? Sorry.
What is TypeScript?
Goddamn. Well, I'll have to invent a slide for that. Hold on a minute. Okay. Cool. So secondly, who's used it in a side project or their own sort of noodling around at home? Cool. All right. And thirdly, who's used it for work, like a job sort of thing? Okay, cool. Interesting. All right. So the reason I ask that is I can vary the content I can spend more time on the basics or more time on the stuff at the other end and just sort of start chopping things when I run out of time, because I will. So let's get on with it. Hi. What is TypeScript? I'll do very briefly. No, TypeScript is a tool a static analysis tool is one of the terms that usually used, but basically a tool that you can run on your JavaScript. It doesn't run the JavaScript so much as it just looks at it on the disk, analyzes it, tries to figure out if it's all internally consistent, if it all fits together, if it should work. So why is, I'm going to sum up with one of my lowercase kind of slide things. I really enjoy I think it's incredibly valuable to write down my assumptions in a way that the computer understands, and then have it tell me when I'm wrong. Like, this is invaluable to me, and it applies to any sort of automated kind of testing stuff, like this types sort of stuff, the tests you write with Jest or whatever. And for me, it's about trying to get the most amount of checking for the cheapest amount, like for the less amount of effort, for the shortest amount of time, etc. Because I really love, the entire point of the tools like this for me is being able to work on a code base and editing a file over here, and when this happens, it'll tell me, I want a goddamn to-do list. This is what I really want from any of these tools. And so TypeScript helps me to get one of these, and also if you work with TypeScript, it'll help you get a more accurate and more complete to-do list. So you can just go through and fix your errors. It'll tell you, you screwed up there and there and there. Thank you, cool. I'll go and fix those errors there, there, and there. Anyway, enough on the why and move on to some of the boring stuff to begin with. But so if you this is going to cover some of the fundamentals. So if you're already familiar with TypeScript, this might be approaching an angle you're not necessarily come at before, but we'll see. We'll get through it reasonably quickly. So we've got these types, and types are sort of descriptions for things. So a type group equals is just a way of sort of making a type alias. Say this type is the same as this other type in TypeScript. And a type, you can think of it as a name for a group of stuff. And the group of stuff are things within that group. For example, we've got Boolean is the name of a type, and the two valid members or two valid values for that type are true and false. So they're two separate things. Name of the bag is Boolean. The values inside are true and false, and absolutely not null, and not undefined, and not 1, 2, 3, or whatever. Similarly, this applies to other sort of things you might be familiar with. So number is a name of another type, and it has these sort of numbers and a whole lot more hanging around, but definitely not undefined. And wait, no, sorry, okay. It's fine. They're floats. They're designed that way, unfortunately. All right, so we've got null, which is the name of a type, null, which has exactly one value in it that's valid, called null and not undefined. It's just literally, that's it, not number either. So you can think of these grab bags or these groupings like this. We've got, so Boolean being the name of the group here, and then true and false. Similarly, number being the name of the group, and then a whole bunch of numbers being the values inside that group, and null being lonely here with its type called null with its single value null. We're going to see things more like that in a minute, but well, actually right now. So we've got another one that's called undefined, and again, the name of it is undefined, and there has one value in it, undefined, and it's not null or any of the others. It's also sometimes called void because it's a more familiar name to some people who use it like as a return signature for functions, for people who use particular programming languages, whatever. It's just another name for it. And so similarly, we've got string as the name of a grab bag of stuff, and we've got our empty string. and our string hello and Unicode and all sorts of things. And also my favorite, the complete works of William Shakespeare. Whenever a function takes a string, I mentally sub in complete works of William Shakespeare because it makes me try to think about what sort of inputs I'm potentially taking. We'll talk about how to shrink this down a little bit so you don't have to deal with old Bill. But moving on to, sorry. Why is the audience on the stage? I don't understand. Can you go sit down somewhere? All right, so we've got this other thing, which is describing like an object. So this is an object which has no like fields or properties. Let's go with fields for the moment. And so a valid value for this is this sort of empty thing. It's the type empty thing, which has a value empty thing. And also some other stuff, but I really want to try and forget this as a possibility moving on. It makes me sad. Anyway, so we've got there. So we started that sort of thing with nothing in it. Now we're going to expand it out a little bit. We've got a type that says it's an object that must have a field ABC and number and nothing else. So we've got a valid thing. True is in fact a boolean and not a number, so that's out. You don't have ABC with this example, so that's out too. You've given us too much in this case. You've given us a DEF as well, so that's out. Except sometimes it kind of allows it with something called literal type widening that makes me sad as well. There are a lot of things that make me sad. I'm going to move right on. But we've got this type group equals brackets, curly things, which may be familiar to you, or like, what the hell is this? I usually use this thing. Turns out they're the same. Basically, type and interface when defining objects are the same, except they differ in exactly one thing, is that you can't use interface, you can't express a union, or some other stuff. But you haven't been introduced to that. It's totally fine. Just if you see type and then a record, like an object kind of thing, mentally sub in interface if you're more comfortable with that. I don't care. It's fine. Moving on. So getting to slightly more interesting types. So we've got, again, a type that is called 123 and has exactly one value in it, 123, and not anything else, or not null or anything else. It's just literally one thing. It's like our null and undefined and other examples. TypeScript lets you define particular kinds of things like strings and booleans or whatever. It allows you to cherry pick values out of that and make them their own type. So we've made a type here. It's called 123 and has one value in it, 123. Fantastic. Why the hell is this useful? I'm ignoring you. All right, moving on. We've got red as, I couldn't even hear him. So we've got red, which is the string, and the name of this is like the string that is red, like the string that is whatever. That's the name, and again, the value. This is familiar at this point, and is just like your null and just like your undefined. You can do this with booleans as well. You can say this thing is only true, and it's the group name true, and it has true or false, whatever. You can start doing this with objects as well. You can say that I want an object that has this particular field, and the value within this is this particular value, this particular type that has exactly one value in it. This starts getting useful in a minute when we start gluing these things together. So let's move on to unions, or types, union types. We'll cover this in some detail. So we've got we've come up with a new grab bag of stuff. We've said we've got booleans, which we're very familiar with, we've got numbers, which we're very familiar with, and we can glue them together. This is a union or like an or. You can think of that bar as like a this or that kind of thing. So valid things that fit in here are true or false or 5. So if we have these circles, these grab bags from earlier, what we can do is we can form this union. We can stick these together into a larger group called boolean or number. And so once we're going to form another grab bag of stuff. So we've made some of them smaller, and this one, for example, is making things bigger, combining these groups together to make a bigger group, and then giving it a name. Similarly, we've got you can do this with like booleans and nulls. You end up with your true, false, or null trinary kind of thing. Where this starts getting interesting, where you might have run into this before, is when you start getting something that say, this represents like loading something from a server, for example. You've got a couple of possibilities. You could see it could be exactly type loading, this specific string type which has just loading, which is in an object, et cetera, et cetera. It's using all the stuff we just saw before. We've got exactly one thing we can construct here, type loading, or the type is this literal string done with the data that's come back from the server. And we can't do this thing down here. We can't have it loading and having some data coming back. We just excluded the possibility. We've sort of designed using the types. TypeScript isn't going to let this through. We've excluded the possibility of it happening and TypeScript saying, yes, it's okay. We've sort of shrunk our types. We've designed it a little bit to only permit the things we actually want to happen, as opposed to just being, hey, I'll have a data and a type and a whatever. So once again, with the circles, we've got this singular type loading thing, and we've got this this done with some data, and you've got this either small grab bag of possibilities for loading or a larger grab bag of possibilities, and we're going to glue them together, and we're going to call it loading or data, whatever. I'm not going to read that out. But basically, we can use the or thing, use the union thing to glue these circles to make a larger circle containing these other circles, these other groups. So let's smash circles together. This is fun. So we've got something here which is like it's called an intersection. You'll see why in a minute. Or it's like an and is how you naturally pronounce it. Like it's an ABC with a number and a DEF with a string, which then leads you very naturally to go, okay, value must be ABC with a number and DEF with a string. And it doesn't permit only one half and doesn't permit only the other half. You need both. The type is gluing two bits together and say they must both be present. So if you think about these separate pieces as, again, their own circles, we can start gluing them to, we can make a new type which is the intersection of the two, where the bit in the middle, the ABC DEF, is the sort of the overlapping, the intersection of the circles of the set, and how and so the only the values in the middle are valid. We've done some set theory kind of stuff. Yay, cool, moving on. There are some other weird types in TypeScript. My favorite one is never. So here is a type, it's called never. So it doesn't have one, it doesn't have high, doesn't have undefined, doesn't have this. Never is even more lonely than null. Never is the name of the set, or the name of the group, or the name of the grab bag, which has nothing in it. It permits nothing, it has no inhabitants, it has no values, it's just called never and there's nothing in it. It's kind of useful when you've got this so there's like using types to do your own sort of computation stuff, and that's not something I'm really going to get into today, but it's something that you're going to run into, and it's good to know what the hell it even is. It's a representation of this, and a lot of type systems, a lot of statically typed things, including TypeScript, have some description of this because it's handy in very particular situations. And so unknown is basically the polar opposite. Unknown allows everything. I mean, it's this, or it's this, or this, or this, and frankly, it's a big, lovely, happy, sort of inclusive garden of any type you want, which is fine. Just you can't really use any of it. For example, we've got a.length, for example, and a is, well, we know it's a string, but we've said it's unknown. And so if you want to call .length on it, it's a case of, well, it might be a number, it might be an undefined, and undefined or numbers don't have lengths. So TypeScript will make you check before you can use it. It permits everything to be put into the bucket, but TypeScript doesn't let you take anything out of the bucket without seeing what it is, without carefully looking at it. So for example, if we've got our unknown value that we know is a string, but let's just say cast it to an unknown to say that, as an example, if we then prove to TypeScript that what we know it is a string, therefore we're allowed to then use it. This is also a concept known as type refinement. We see we're refining a type down from the innumerable possibilities of unknown to it's a string. We know what to do with strings. We can do lengths on it. Congratulations, cool, we can move on. We're going to come back to this a little bit later because it's a deeper topic that's also going to be useful. But moving on, we've got any as a favorite type that you might have run into already a lot. And it's basically all these values are any. And any is basically a this for TypeScript. It just turns off TypeScript. It's kind of almost like any value, and any value is kind of like kryptonite for TypeScript. It's like, whoa, I don't care what it's short, whatever. It's just like a TypeScript is rendered powerless by your invocation kind of thing. And so it means you can ask for a pony and it'll blow up at runtime, and TypeScript will say, sure, I don't care, whatever, and just lets it through, and well, your pony's going to explode. I don't really know what I'm doing with this metaphor. I'm going to move on. So let's talk about possibilities, but first, a drink of water. So we're going to use some of the concepts we just learned in order to design a system, design types in our system a bit better, to take advantage of TypeScript. So one principle is include. I really need a better title for this. How about we go on to the example and go from there? We've got something that will basically say, for example, it's going to return us a string. And we're just going to make something like a class that we'd use with CSS, for example. And we intend for this to be like a spinner or a loading thing. So type could be a spinner, type could be loading, and that's totally fine. But the thing is, the type here is a string, and it means that we can't. TypeScript is like, sure, I'll allow it to be a string, and then inside this function, you're going to need to like do the check to see if it's a spinner or whatever, and otherwise throw an exception. Basically, instead of being able to do it before you run the code, and allowing TypeScript to check this before you run the code, instead you need to then switch this to like some runtime like exception throwing stuff. And it means that TypeScript is like, sure, whatever. You're not taking advantage of TypeScript's sort of capabilities here. So what we can do is use TypeScript to say that, no, actually with my input, I mean, it's an icon. It has exactly two possibilities, a literal type spinner and a literal type save that is being used with union to glue them together. We have two possibilities for here, which is spinner or save, instead of, once again, the innumerable possibilities of string. So with all that, we've many, many possibilities of string, but with spinner and save, we have exactly spinner or, wait for it, save. Whee! It's useful. So we've basically taken the possibilities from approaching infinity to 2, which is kind of useful. Fewer things to think about, I think. All right. So another thing we can do is avoid spreading like a singular choice or like a singular switch, you'll see what I mean, across multiple sort of values, multiple sort of input values. So if we've got a React component, I hope some people in the room are familiar with React, but I will be very quickly explaining it so that it's not, whatever. It'll make sense even if you don't know React in a minute. But basically, we've got a function like notification that is a React component, but whatever. It takes some things, and it's taking an object, and there are three flags on it. Whereas, saying success or warning or error. So you've got a notification component. You use it, and it's like, it's an error, true. This is bad, fantastic. This makes totally sense, and it makes total sense. And if you're not familiar with React, it's kind of like calling a function with whatever. Who cares? Anyway, it's a component. So you can say error, true, and then all the rest will be defaulting to false or undefined or whatever. That's great. This is fine. Like success is true is fine. And I mean, it allows some other stuff though, like this. So a success and it's an error? This doesn't seem useful. So what we can do is we can take our component and we can sort of rearrange the API, the types a little bit so that we can take advantage of, again, TypeScript to reduce the possibilities that don't make sense down to the ones that do. So we take these 3 fields and we turn them into a single union of possibilities. It's now not possible to use it incorrectly, where in the case of type is either success or it's an error or whatever, and you can't have like success and error. You can't even like write it down. This is useful without TypeScript, frankly. It's just you have to deal with some extra whatever. And so using TypeScript to unions and these literal strings to describe exactly the possibilities you intend is a very useful sort of concept. And what we've done is we've taken these multiple flip-flop choices and turned them into exactly one choice that can be set to one of these 3 values. And once again, we've taken a bunch of possibilities, which is 8, and turned it down to 3, which I consider a bit of a win. So there are also things that change separately. We were talking about changing these 3 flip-flops and replacing it with just 1. Sometimes that's totally fine. We've got our choice for our success, warning, and error, and then we've got Boolean, which is whether this thing has a little X in the corner to dismiss the notification or whatever, and that's fine. You can have a success thing as dismissible. You can have a warning that's not dismissible. It changes independently, and so therefore you don't need to try and glue it together. This API is fine. This API describes all the possibilities, all the different ways you can use it correctly, and so you don't need to feel the need to glue everything into one massive union type. It's a case of these things are changing independently. They're totally cool. Move on. Ooh. So convenient types are tempting but can sort of leave gaps that allow possibilities, allow inputs that are kind of wrong. And by convenient types, I mean, for example, something like an array, which are useful, and we're going to still keep using them, but it's a case of we can use our array slightly differently and therefore like restrict things a bit. So this is a carousel that is a component that takes some items to display in a carousel. Like one of the ones you got on a website, it's a big banner thing. There's always like at least one item hanging around in it, and there may be more, and you sort of click around. Anyway, so we can say we've got this list of items that we're going to give to the carousel and display it. This API allows us to say this, and this will totally type check. It'll be fine, right? Except like now we need to handle we need to handle like what if there's like nothing, no items. We need to go and design an empty state for a carousel that arguably shouldn't even be on the page if there's nothing to display. So let's redesign our API a little bit to allow us to preclude the possibility of empty things. So if we take this list of items we already have and turn it into a sort of before and the current item and then after, it means that we can design it so that we can preclude that particular possibility. So for example, this sort of represents the things you're currently looking at. You've got the items before and the items after, and that's empty, but the item itself can't be empty. You've made it so it's like a non-empty kind of list. It's a list that can't be empty, even if it's split across 3 pieces. You've split your array into 3 pieces, and in doing so, have made it so you can't use it incorrectly. Let me see. So one larger example, just to take some of these concepts and glue it together. So we've got a larger React component. Don't feel the need to read through all this. We can represent this as kind of like just a single type. This is using hooks for anyone who's had a go at them. But we've got a type that is loading or is an error, and a data that is maybe nil or string, because we need to like initialize it, because when it's we've got a bunch of extra states in there, and it feels like this is sort of not optimal. For example, valid cases, we've got no data yet, and we're loading, and it's not error. Congratulations, cool, this is totally fine. Also is like we have finished loading, and there's no error, and there's some data, great. Or there was a problem loading, there's an error, and there's no data, fantastic. It's loading, and there's an error, and there's data. I mean, I'm not really sure what to do in this kind of possibility. So we can try redesigning this API using the tricks we just learned again, which is, once again, reducing it down to the states you specifically care of. You design it as like, I want it to only be loading, or an error, or a success with some data. You can muck around with this. You can say, oh, data might come back empty, so that data is string or null. You can massage this or add extra possibilities, but you're designing the types as opposed to just adding some booleans, adding some strings, and then just hoping that the invalid combination never shows up in your program. It's the idea of making invalid states impossible, making impossible states impossible. There have been a few talks and blog posts on variations on that, and when the slides for this go up, I'll include a link to a couple of them. So let me see. Okay, so one thing I do want to cover is exhaustiveti, which is this comes back to the to-do list concept from earlier, where we've got some inputs. We've got our spinner and our save, and we want to make sure we've matched all of them. And so doing this, it will mean that we've matched all the possibilities. TypeScript will be happy. Our code will work. It's fine, fantastic. So we go and add another kind of icon. We go and add an OK icon. And then TypeScript will actually figure out you're missing something. It'll say it's got this horrible error message, like function lacking return statement and return type does not include undefined. What the hell? I thought Haskell had worse errors than, anyway, whatever. It's suboptimal, but it at least tells you, like, by the way, you're sometimes returning undefined, and so if we add the possibility for this OK icon, suddenly TypeScript's happy, and it's good. Basically, this can happen from within the same file. You can add a type over here, and the function that's using the type is in the same file, fantastic, or it's in different parts of the code base. But the thing is, if it is in a different part of the code base, you change it, you add it, and then a bunch of things will say, by the way, I need to be updated, please update me. I get my to-do list. That's exactly what I'm here for. Exhaustiveti plus the unions thing is like what I'm using TypeScript for, and everything else is practically incidental. Exhaustiveti is like a really, really useful feature for any type system or tool using unions. There's the unions plus like these possibilities that you sketch out. And there are other sort of things as well where you can do exhaustive checks on different types coming in. And this in itself has a larger sort of guide on the TypeScript language thing. Again, I'll post the links up so you don't need to scribble down that thing in gray. Okay, all right, I'm going to press on with a couple of things and then I'll wrap it up. So I've got one other thing you can do with TypeScript is making intentionally different types. So if you mean something different, using a different type. And so the canonical example of this is like numbers, which like a number can be like a row ID, an account, and a currency like an AUD sort of cost or a kilogram or stuff. And strings work in a similar way. You can have a whole bunch of possibilities there. So it means that if you've got a string and a string, you're not differentiating either of them to TypeScript. And so you really want to make it obvious to TypeScript that they're different in some way. or at least do some way so you can't mess around, so you can't accidentally get the order of things wrong, as we'll see in a minute. For example, we've got save user, which is taking an ID, which is a string, and an email, which is a string, which is fantastic, and returning, the promise of a new user. The thing is, you can very easily, mess this up. And so one way we can try and differentiate things, instead of taking two strings in a particular order, is to, instead of two strings, take two strings inside an object which has some labels. Basically, like it takes an ID and an email, and even if you flip the order around, you've at least had the descriptor sitting next to it. It's not foolproof, but it's a useful first stab at trying to differentiate these things. Because yeah, you've got two strings, and it's going to be really easy to get those messed up. And it's just kind of awkward writing it like this, so again, you can pull it out to a type or interface, whatever, as a way of describing the input to the function. It's a little bit longer, but frankly, I find it easier to read sometimes. So what we've got here, though, is when we've got our save user, and maybe we've got some other functions that save user then in turn calls, we've got this string that we've passed for, we're doing something with the ID, which is a string, and doing something with the email, which is a string, and suddenly our type safety is evaporated again, because again, we're just dealing with strings being flung around. So we can try and preserve that information that it was an ID, preserve the information that was an email, using something called brands or opaque or nominal types, and it's got a bunch of different names. And this is kind of a scary thing, and you just pay attention to the pink bit. It's just brands with a couple of parameters rather than the rest of this horror show kind of thing. So I'm just going to quietly just gray that out and move on. So what we're doing is declaring a user ID, which is it's basically taking advantage of a bug. Something is almost a bug in TypeScript, but it's stable enough. It seems to have worked for ages, so whatever. But it's using, we're declaring a new user ID type, and we say it's a user ID. And then we can say that we can sort of cast something into this, either through a validation function or just directly, so that it's a user ID, and that information is going to be preserved. Such as we've got this ID, which is user ID, and an email, which is just a string. And if we've got a function that expects user ID specifically, it'll work with the ID, and it will, more importantly, fail with the email. If you specifically use user IDs and something you require as input, you can then have TypeScript check that you've already done the work to verify that's the user ID, instead of repeating over and over again that, is this a user ID? Is this a user ID? It's a case of you've already got it as type information, and then TypeScript can use that and check it for you. It just involves a whole bunch less rework, and again, it's taking advantage of TypeScript in order to check some of the stuff for you. And you usually end up with like pairs of functions like this, where you're taking a string to user ID, and that can fail, or a user ID to a string, which is always going to succeed because it's just an easy transformation. And so it means that we now have this user ID information. And so the user ID information, if you then use it in this, this function, will then be passed around to the other functions that expect user ID, and that's preserved. Oh dear, okay. I'm going to wrap this up in 2 minutes, and then there's going to be some material that I'm just going to skip on straight past. I'll make sure the slides are available, but it's stuff that I'm definitely not getting to get to. So something that is also very useful as a thing is proving things to the type checker, and we've already done this in a way. We've sort of refined this unknown type. We've taken this thing which is an unknown thing, and then checked, we've proved it to TypeScript that the thing inside the if branch, which is supposed to be an A and not a D, pardon me, is actually a string. We're taking something that's unknown to a very known thing. It's a concept that you're going to run into when you have APIs. You can have some big massive mess of like, so if you have a function where you've got to take an unknown and it returns a very known thing, like a message with a string, where you're taking some information from the outside, like via a JSON API, and turning it into a known type within your program, you can write big messes of this code. But there is a nice way of doing this called type guards that lets you write a whole bunch of these things in a more compact fashion. So, for example, this is a type of a string that we've already seen, but then we can come up with our own type guard that compresses it to isString, for example. And we can use this feature called type guards to write functions that will sort of prove bits to TypeScript. And so we can write these little functions we can combine together into larger functions to make validation of external or unknown inputs, such as stuff from JSON API, provable to TypeScript. So you can rely on TypeScript to check your input validation, as opposed to just casting it to any or casting it directly to your thing and hoping it's going to work, or hoping your API is going to stay the same. So this isString is a type guard, and then we can clean up our unknown to our known internal API, so our unknown to known type from this big mess of directly checking the type of object to like, is an object, does it have this particular key? Is this thing a string? Great, return my new thing, otherwise throw an error. It allows you to clean up a whole bunch of this validation code, take advantage of TypeScript's unknown to known kind of setup that it allows you to do to validate incoming information and yeah, basically have a safer program. And this is where stuff like IOTS is like an evolutionist sort of idea, where you sort of define a type contract as like a thing that's taking a couple of strings, and you also get a type out of it as well as a bunch of validation stuff. Anyway, I'm going to skip ahead and wrap this up because I am half-hour mark, and I'm going to. Well, actually, lightning round is going to be exactly like 30 seconds. So, briefly, please use strict. Oh god, oh god. Avoid numeric enum because it is all sorts of unsafe, because you can say, here, I could take 1 or 2, and it says, sure, you can put in the devil's number, and it just allows you to. String enums are fine, just cool. There are a whole bunch of useful utility classes, like read-only as a way of, and a whole bunch of other stuff like take this type but remove this particular field, whatever. Types first interface I mentioned earlier, there's a big long exhaustive listing exactly why they are the same, because it wasn't previously and now it is. Literal type widening, which is an eye widening experience. I'm not going to look at this slide. Cool, wrapping it up. So if you shrink the possibilities for input and output as closely matches what you're in, closely as match what is going on in your head as you can muster. Use exhaustiveti to give yourself a to-do list of stuff to change when you update union types. Use different types when you mean different things. Try and differentiate your types so the TypeScript can have your back. Prove things to the type checker so it can do the work for you, as opposed to just, hey, I'll just cast things to any or things directly to a type and just hope to God it works. And please don't use numeric enums. Thank you very much.